my name is Rakshita. So today I'm going to talk about the classification model which I built for package delivery route optimization. So first we are importing all the necessary packages. Then we are reading our data set. We are importing our data set into Python by using the pd.read underscore CSV function. So since our data set is in the form of a CSV file, we are using read underscore CSV. So then we are my predicted columns are going to be delivery status. So since it contains three types of three categories: delivered, pending, and failed, I'm converting it into two categories. If it is pending and failed, then it is not delivered, otherwise it is delivered. So that is what this line does. So df of delivery status is equal to df of delivery status dot replace pending as not delivered and failed also as not delivered. So then I'm going to encode my data, categorical data, uh, so which is origin, destination, and priority. So everything has different categories. So origin is like the warehouse, which warehouse it is from, and destination is to which destination it should be delivered, and priority is how fast it must be delivered. So since all these three are categorical, I am encoding these, and that is why we are using this for loop, and we are using a label encoder to encode these variables. Then I also have to encode my delivery status, which is currently delivered and not delivered. That will be converted to 0 as 1, 0 and 1, 0 as delivered and 1 as not delivered. So we are assigning a variable target encoder which contains the label encoder function, and we are encoding the delivery status column. So then what we are doing is time window start and time window end. So what this is, it contains the time period, so the starting and ending time of the delivery. So since all those is given in string, we are converting it into numerical. So it is taken as a continuous time. So it is taken as continuous value. So we are converting it into numerical using the lambda function. Then we are dropping the columns package ID and delivery status for the X variable, as X contains the independent variables. Sorry, X contains the independent variables. Uh, in that we do not need package ID as it is not really necessary. And then the delivery status. Delivery status is going to be our dependent variable. So that also we remove from X. And then Y is our delivery status. Then we split the dataset into train and test values. So test size is 0.2, meaning 20% of the dataset is test and 80% is train. So then we are using a scaler, standard scaler, so that all the values are in a similar range and we reduce the possibility of outliers. And then we transform the data X train and Y train. Sorry, X test and X train. Then we build a model. It is a random forest classifier. It is used for classification tasks, so I chose this model. And then we are fitting the data X train and Y train, and then we are building the model. Then we are predicting the model values. This is the prediction from the test data. And then we are generating a classification report which contains precision, recall, F1 score, and support. So that is all for today's classification model for package delivery route optimization. Thank you.